Okay folks, so first and foremost, we must have a fresh look at White's heteroscedasticity consistent variance covariance matrices. We had a look last time, but I think we should have a more detailed look at the whole process. The first idea that we need to understand is the idea of a leverage. What is a leverage? You know, in the matrix form, y is equal to x beta plus e. Okay? You have y hat is equal to x beta hat. Okay? Right? We have e is equal to y minus y hat. Okay? Right? Now this here, so basically what we can write this as, so let y be equal to x beta plus e. Okay? Right? Minus x beta hat. Right? X beta plus e minus x beta hat. Now, what is x beta hat? We do x into x dash x inverse x dash y. Right? Sure? So this is e hat. I should call it e hat because this is estimate. Right? E hat. Right? Okay. So x into x dash x inverse x dash y, which is what? Which is x into x beta plus e. Right? Okay. Which is nothing but, so we have x into x dash inverse x dash x beta plus e. Right? So this is what we have as 1. Okay? Right. So now, if I put both the things together, so this is what, this will simply be right, so x into x dash x inverse, x into x dash inverse x dash y, and for y I have x beta plus e, so x into x dash inverse x dash x beta plus e. Okay. Right. Here, we talked about this matrix in the last class. What is that matrix called? The hat matrix. That matrix is called the hat matrix. And we showed in the last class, okay, that if you do this, if you write y, e hat is equal to y minus y hat or x beta plus e minus x dash beta, which is what? Which if you simplify this here, this will be x beta plus e minus, what will this be? If you simplify this, if you open these brackets out, this is going to be x into x dash x inverse x dash x beta plus, okay, let me write it somewhere else so you can more easily see that. Can I write this off and write it here? Yes. Okay. So this will become x into x dash x inverse x dash x beta plus x into x dash x inverse x dash e. Right? Okay. So these two will go and you will have x beta here. So we have y hat is equal to this. Okay? So if I subtract from this, what will I get? I can get x beta minus x into, yeah? Right? Okay. Now this x beta will go here and This can be written as the identity matrix minus x into, sure? I've taken the E out column. Right, so this is E hat is equal to I minus x dash inverse x dash E. Okay, sure? Okay. Now, let's understand what this matrix is. What is this I minus x dash x inverse x dash into E? Okay, we'll take a very simple example. So think of a simple one variable regression where there is one dependent variable n cross 1 y, there is no constant, there is just one x. So x is again an n cross 1 matrix, beta is a single number plus E, so E is again another n cross 1 matrix. So think of a very simple structure like this. So you really have, so we have y is equal to y1, y2, say y3, keeping things as simple as possible, right? Let x be x1, x2, x3, right? Let beta be just beta, a 1 cross 1, okay? And let E be, say E1, E2, E2. Let E be E1, E2, E3. A very simple model. Now, let us try to construct this. What will be, first, what will be the dimension of x dash x? X is n cross 1. So, what is x dash? 1 cross n. What is x dash into x? 1 cross n into n cross 1. So, 1 cross 1. Yeah. X dash x inverse would be 1 upon that, so it will be a single number, x dash x. It will come in the x dash x inverse will come in the denominator, right? Okay, sure. And x will then be an n cross 1. What will be in the numerator will be n cross 1 into x dash, n cross 1 into 1 cross n. So we will have an n cross n matrix x dash x, where each element will be divided by a single number x dash x. You learn the identity matrix will be an n cross n. I minus that into E. E will be an n cross 1 matrix. We give you E hat. So let us try to work out this algebra. Okay, just to see what this matrix means, right? Because that's important to understand when we deal with how to deal with heteroscedasticity in constructing robust standard errors. We need to understand these matrices properly. So let's try to construct that. So first, can you tell me what will be x dash x? X dash x is simply yeah, right? Which is what? What is x dash x? Summation xi square. So this is summation xi square is equal to x dash x. Therefore, x dash x inverse is equal to 1 upon summation xi square. Right? Okay. Now, what is x into x dash? X into x dash will be x into x dash will be x1 square, x1, x2, x1, x3, x2, x1, x2 square, x2, x3, x3, x1. That is x dash. We want x dash x inverse x dash. Sure? So that is going to be, therefore, x dash x inverse x dash will be 1 upon summation xi square